Hello, welcome again. We are covering the subjects thermodynamics for civil services mains, IFS, and various GATE exams. We have just finished the topic Clausius inequality. Now we will solve some questions based on this topic Clausius inequality, which is another chapter of entropy. Question number one is: a thermal cycle receives 2000 kJ of heat from a heat source at 1000 Kelvin. It rejects 300 kJ of heat to a sink at 300 Kelvin. Also rejects 250 kJ of heat to another heat sink at 200 Kelvin during the cycle. The cycle is option A reversible, option B is reversible, option C impossible, and option D work absorbing. So first of all, we will find out the cyclic integral of dq by t. If it comes out as negative, then the cycle is irreversible. If it comes out as positive, then the cycle is impossible. If it comes out as 0, then it is reversible. For 0 it is reversible, for negative it is irreversible, for positive it is impossible. So first we check these three options. So uh, cyclic integral dq by t is q1 is heat received, that is 2000 at temperature 1000 Kelvin, so 2000 by 1000. q2 is heat rejected, that is 300 at temperature 300 Kelvin, so 300 by 300. q3 is heat rejected 250 and at temperature 200 Kelvin, so it will be, so result will be a minus 0.25. Okay, so this is the cyclic integral value. So it is coming out negative, so it means cycle is irreversible. Now we will check for this work absorbing option also, because q1 is your 2000 and q2 is 300 and q3 is 250, and these are heat rejection, these are heat received. So it will be the difference of heat or net uh, change in heat is positive, so it is equal to work done according to cycle, according to first law of thermodynamics. So that is 1450 kilojoule. So it delivers work, it doesn't absorb work. Okay. So this is q1 and it heat rejection is 300 and 250, heat received is 2000. So answer is option B. Question number 2. Consider the following statement for an ideal gas undergoing a reversible non-flow process. P. If the process is adiabatic, the change in enthalpy of the gas is necessarily zero. Q. If the process is adiabatic, the change in entropy of the gas is necessarily zero. R. If the process is isothermal, the change in enthalpy of the gas is necessarily zero. S. If the process is isothermal, the change in entropy of the gas is necessarily zero. Which of the following statement options is valid? Option A only P is correct, option B only C is correct, option C only Q and R are correct, option D only P and S are correct. So here we check the first option. Enthalpy has no relationship with the adiabatic process, so this is a note there. In an adiabatic process, heat transfer is zero, but enthalpy we cannot say. Okay, so this is wrong. And Q, if the process is adiabatic, the change in entropy of the gas is zero. That is correct, because the process is reversible. For reversible adiabatic process, the entropy is constant. So change in entropy is zero. So this is correct. If the process is isothermal, the change in enthalpy of the gas is zero. That is also correct, because for an ideal gas, the enthalpy is the function of temperature volume. So answer is option C. Q and R are correct. Next question, question number 3. The Clausius inequality holds for option A any process, option B any cycle, option C any reversible process, option D only reversible cycle. So we know that cyclic integral of dq by t is less than equal to 0. that is your Clausius inequality. For reversible process it is equal to 0, and for irreversible process it is less than 0. So it is valid for any cycle, closed this cycle. So answer is option B. Next question, question number 4. The following statements are given. 1. The third law of thermodynamics deals with the entropy of a substance. 2. The entropy of any non-crystalline structure is 0 at absolute 0. 3. At the absolute 0 temperature, the crystal structure has maximum degree of order. 4. The thermal energy of a substance at absolute 0 is maximum. Correct option describing this statement is option A, only 1 is correct. Option B, only 2 is correct. Option C, both 1 and 3 are correct. Option D, both 1 and 4 are correct. Okay. So according to third law of thermodynamics, the statement is it is impossible by any procedure, no matter how idealized it is, to reduce any system to absolute zero of temperature in a finite number of operations. So in a finite number of operations, the system cannot be reduced to zero, absolute zero temperature, because it is an ideal condition. So as absolute zero is an ideal condition, so it will have maximum degree of order, no randomness, no disorder, okay, and entropy is degree of disorder, so it is an ideal condition. So answer is C. First is correct. First is third law deals with the entropy, because it is describing order or degree of randomness, okay, and at absolute zero it is the system is having maximum degree of order, no, almost no entropy change or no disorder. So answer is option C. Both 1 and 3 are correct. Next question, question number 5. A reversible engine receives 40 kilojoule of heat from one heat source at temperature 127 degrees Celsius and 37 kilojoules from another heat source at 97 degrees Celsius. The heat rejected to heat sink at 47 degrees Celsius. So here again using Clausius inequality, so from 400 it is receiving 40 kilojoule, 400 Kelvin, 127 means 400 Kelvin, and from 370 means 97 degrees Celsius, it is receiving 37 kilojoule, and it is rejecting to 47 degrees Celsius, that is 320 Kelvin. So using Clausius inequality Q1 by T1, that is heat received, this is also heat received, and this is heat rejected, so it is negative. So we can find out Q3. T1 is 400, T2 is 370, T3 is 220, Q1 is 40, Q2 is 37, and Q3 is, will come out as 64 kilojoules. Next question. A reversible cycle device absorbs 400 kilojoules per second heat from a reservoir maintained at 265 Kelvin and rejects heat to another reservoir at 298 Kelvin. The magnitude of rate of work done by the device is option A 849.81, option B 449.81, option C 355.7, and option D 49.81. So here for reversible cycle, again we have Clausius inequality. If Q2 is heat rejected, then it will be negative here and positive here. So Q1 by T1 is equal to Q2 by T2. Q1 is your 400 and T1 is 255. Q2 is unknown and T2 is your 298. So Q2 comes as 449.81 kilojoules per kilogram. So now we have Q1 and Q2. We can find out the work done. That is Q2 magnitude of work done. Q2 minus Q1 or Q1 minus Q2 magnitude. We have to find out, that is 1481 kilojoules per kilogram. So answer is option